Perfect. Yeah, let me introduce myself real quick. My name is Sven Oehme. I'm the Chief Research Officer of DDN. I was invited to give the keynote talk today, so I thought it's very appropriate to start off with a little bit of history of Samba that I experienced myself. And surprisingly, when you look back, when you had first contact with people and software technology, it's always interesting what you find. So actually this week, for the first time in a couple of years, I had to check out the Samba Git repository to just take a look at some of the history. And I found a couple of interesting things, which also reminded me that I'm working in this industry for over 25 years by now, which is quite a while. So in 1998, I started working on a distributed file system called AFS, stands for Andrews File System. Some people in this conference might actually still remember that. And I started actually interacting with Samba for the first time during this year because I basically tried to get Samba up and running on top of that in order to share some of the data from that distributed file system, which at that time was exclusively be mountable by Unix machines. From Windows machines. And so we were using this to basically collect data from various machines in manufacturing, store the data in a distributed file system, and then run some analytics on Unix systems that were far more powerful at that time. So around 2000, it was the first time that I actually worked together with Volker, which was a very interesting experience. And so Volker basically worked together with me and a smaller team in IBM to fully port Samba to run on AIX. I know Jeremy contributed lots of patches in that area as well. And so we basically made it work on top of AFS, which was quite interesting because it was a Unix file system that actually had real access control lists. And there was quite some work required in actually to make that work properly. And then I started working on GPFS, or these days known as Spectrum Scale. And so I had more and more interactions with Volker and the whole Samba team. And around 2005, I was asking Twitch to join me in a development meeting in Mainz, and Volker came as well to Germany. And so I basically challenged both of them to come up with an idea how we can actually make Samba clusterable, and basically run instances on multiple nodes in a distributed storage system and see how we can actually export the data. And so both of them were actually quite negative at that idea at the beginning, that this is really hard and we're not going to be able to do this. And guess what? On the way to pick up some pizza, we actually came up with this great idea how to make it work. And that actually started the work on a sub-project in Samba called VL Messaging at the time, which was basically the first prototype in order to build CTDB, which then ended up in 2006 in the first commits of CTDB, where we actually for the first time showed that Samba can be clusterable, and actually you can get a net gain performance benefit by adding more and more resources into it, because all the previous attempts showed as soon as you go from one node to 2 to 3 nodes, you actually see a decline in performance. And with this approach that we invented with CTDB, we were able to show positive scale going from 1 to 2 to 4 nodes and so on and so on. So some of the technology actually ended up in a service offering that I was working on in IBM called SOFS, which later ended up in a product called Scale Out NAS, ONAS. And then DDM, the company that I'm working for now, in 2016 actually also started a product based on Samba called Media Scaler 2.0. And that was a product that was primarily designed to handle media and entertainment workloads on top of a clustered file system. And so since I joined the company, I refocused again some work around Samba. And so in 2019, we started shipping data services for XR5, and I have one or two more slides talking a little bit more about the details of that at the end of the presentation, where we're leveraging Samba quite heavily as well as CTDB and a few other components in order to provide scalable file services into a distributed storage system, leveraging native clients like NFS and SMB. So who is DDN, the company I'm working for right now? So DDN is the world's largest privately held storage company. We basically have two divisions. There is an at-scale division that focus primarily on deep integration into high-performance computing systems and AI, machine learning systems. So very heavily focused on analytics and research. And then we have an enterprise division that focus primarily on enterprise application. So we have products, and I'm going to talk a little bit about that, that are highly optimized for virtual machine workloads. So SMB is obviously a key player here for Hyper-V integration. And we also have support for containers. We have some of the larger database workloads running on top of our products. And we have quite some scalable object storage solutions as well. So our customers are a large number. As I said, the company is quite large. We have over about 1,000 employees. We have over 10,000 paying customers today. This is just a small subset of logos of customers that we are supporting. We have 10 technology centers all around the world, 150 plus patents across our different product portfolios. And we basically deliver anything at scale for mission critical workloads, research, everything you can imagine that has to do with storage. We have a solution in our portfolio. So who are our customers in a little bit more detail? And I was trying to pick a couple that are more focused on workloads that also interact with SMB in our case. So we have a large number of solutions, as I mentioned, but AI and analytics solutions is really one of the key areas where we not just invest, but where also the majority of our customer base comes from. And that could be all kind of solution. This could be autonomous car development. We have a lot of work going on with financial customers and also a lot of low latency design systems. So some of them are interacting more through SMB, some less with SMB. But SMB definitely plays a pretty big role in pretty much all these new deployments that we have, which is why we actually have a variety of SMB stacks in use in the company, which I'll talk a little bit more, but Samba is definitely one of them. So to give you an idea on what some of these systems look like that we deploy, here is one prime example. So NVIDIA, who is not just a partner, but also a huge customer of ours, is designing what they call superpods. So superpods are super large-scale analytic systems based on their GPU acceleration technologies. And so we got challenged shortly before Supercomputing 19 last year, where NVIDIA reached out to us and said, hey, we have this huge requirement. We need a system that can deliver over 1 terabyte per second throughput. And we need, somewhere around 10, 15 petabytes of capacity. And we need a solution that we can bring up very, very quickly because there's only a few weeks left until Supercomputing 19. And we would like to basically show a super stellar benchmark and show the world what you can do with a very, very powerful GPU based system. And so NVIDIA deployed a larger number of DGX systems in the lab. And we came in and within 4 hours, we installed 10 of our AI 400X appliances. And so the system was basically up and running in 4 hours. And this was just a small subset of the total system, but this was what was required in order to meet the benchmark requirements. And so within 4 hours, the system was up and running, delivered over 400 gigabyte per second throughput. We delivered over 80 gigabyte per second throughput into a single DGX. So that means a single client can read and write at about 80 gigabytes per second, which is obviously a pretty high number. We achieved this using 8 100 gig network adapters that we used in the multi-rail configuration. So we basically used all networking adapters at the same time. And basically within a couple of hours, we got a system up and running and run a benchmark that at the end was the fastest production system in the IO 500 10-node challenge, which was obviously quite some accomplishment. So this is one example of things we do. We also have a couple of deployments actually with autonomous driving companies. So this is just one example. The system delivers 1.6 terabytes per second throughput. That particular customer collects between 80 and 200 terabytes of data per car per day. So it's a quite significant amount of data that is being collected. And so the data is pushed into the regional data centers, and they want to offload the data as fast as they possibly can. So they need very, very fast connections into that. And the customer was looking for a very cost-effective way for doing this. And so we delivered that to them with one of our exascaler product solutions. So European autonomous driving, pretty same story. Customer needed multiple installations. They didn't want to just deploy one very large system. They wanted to deploy multiple systems at a certain size. So they picked 27 petabytes and 200 gigabytes per second throughput as kind of their optimized building blocks. And then we deployed several of them into the system. And we have a very efficient monitoring system in place around that to basically monitor multiple or single individual instances with very, in-depth visualization of performance and availability data across the entire system. So let's talk a little bit more about some of these products and also specifically about where SMB is going to be used and what we're doing with this. So the DDN portfolio, so this is the at scale portfolio. So that's one that is focusing primarily on HPC and AI. I also have a slide for some of the enterprise products, but let's focus on the at scale side first. So on the at scale side, we have a couple of different products. So IME is an all-flash cache acceleration technology. So you can basically put this in front of an existing file system. It provides a user space client for Linux machines. And you can basically mount this, and then you can read and write into it. While IME itself is not a file system, it essentially caches all data that goes in and out of a file system, and basically sends metadata requests directly to the backend file system. So see this really not as a file system replacement, it's an accelerator for an existing file system solution. And it supports multiple backend file systems from NFS over GPFS, over Lustre, several other POSIX-based file systems can be accelerated by that. Then we have our Exascaler 5 product, which is essentially a hardened enterprise version of Lustre. So DDN owns the former VMcloud development organization that was part of Intel, that is the main driver behind Lustre open source development. So we do about 80% of our code commits into the Lustre open source space. So we're the largest, by far largest contributor to Lustre. And so Exa 5 is essentially our enterprise version. It has a lot of additional capabilities on top of what the open source version provides. And we sell this under our Exa 5 brand. SFA is a highly scalable block storage system. It has no enterprise features. It's just very fast and resilient. And we essentially use this to run file system and object solutions on top of that, leveraging the SFA building block as just a very fast storage device in order to basically support some of the file systems that we run on top of it. A3i is a highly integrated turnkey appliance that essentially provides the file service capability embedded into a filer, and I have a picture that makes this a little bit simpler to understand. But think about it as a turnkey appliance, very, very fast, very predictable performance, a couple of different capacity points, and you can use it to basically build a scale-out solution. You start with as little as one, and you essentially just add more and more into it in order to reach whatever scale that you need for your AI system. And Dataflow is a data management solution that allows you to synchronize, backup, and archive data. So it has multiple sources and multiple targets it can connect with each other. And you can basically do this to backup data, archive data, migrate data, move data from file to object, from object to file, file to tape, has all kinds of connections between them. So in order to understand how these filers look like and where SMB basically runs, is you need to take a quick look at the hardware itself. So what we have is basically four fundamental building blocks. There's a 200 NV, a 400 NV, a 7990X, and an 18KX. And so the only difference between them is what media you can put into them and what speeds they have. But the operating system inside, SFAOS, is the same on all the individual products. And the only difference is that the first two are head units that contain NVMe drives. The 400 has the capability to add several SAS expansions to it to basically provide SAS capacity besides just NVMe capacity. The 7990 is an all SAS system where it can fit up to 450 drives through multiple expansions. And the 18K is our largest scale system. It delivers over 76 gigabytes per second throughput, 3 million IOs per second in a single chassis, fits 48 NVMe drives in the head, but then you can attach up to 20 expansions to it. So it can basically build a 25-ish petabyte storage system with a single head unit. So this is just building blocks, but the real key differentiation is not just in the hardware, it's actually also in the software that runs on top of it. And so in order to simplify the view on how we did this is when you look at a traditional distributed storage system, what customers typically have is you have a client, you have a NIC, there is some switches in between. You go to another NIC and then you have a file system server, you have some HBA, SAN switches, another HBA and some storage. So it's actually a pretty long path typically with many, many components, particularly in a scale out solution. And what we've done with SFA is that we basically put virtualization technology inside the hardware platform itself. So instead of having external servers that consume storage that run a file system solution on top of it, the entire file system stack, the NAS stack, everything is completely embedded in the hardware, leveraging virtualization technology. So why does it matter? That matters a lot because modern systems are heavily NUMA systems. So you have various memory channels, you have various dedicated sockets that have direct connection to some NVMe media and some network adapters, while other network connections or other NVMe media might be connected to a different socket. So basically you have to traverse between sockets and interconnects all the time. And by putting a virtualization layer inside our SFA platform, we can basically channel all the IO that comes into the system and goes to the storage completely within its NUMA domain. And that provided us significant performance and scalability benefits. And that's the reason why we can, for example, deliver out of one of those 2U systems over 40 gigabyte per second throughput, because we can use the full capabilities of the hardware by being essentially so low level detailed on how individual processes get scheduled, on what NUMA node they run on, what network adapter they communicate with. And that's one of the key essential differentiations of what the SFA platform together with our software stack provides. And so what the software stack looks like is basically try to visualize this in a picture here. So Exascaler or Exa5 is the latest version that typically runs inside of these filers. We have different incarnations of these filers with different software stacks on it, but the most popular one is Exascaler, which runs our Exa5 file system in it. Exa5 has a lot of very cool, unique features. You can very securely create multi-tenant separations. So you can have basically mount points in a single shared system where you designate individual mount points to individual consumers, tenants, and they will be securely be able to access that, which means this goes beyond just simple access control list separation. You can actually hide individual files paths from individual users. And we also have the possibility to, for example, root squash root users on the clients. So even you root on the machine, you're not going to gain root access to the file system, which is something that is key if you deploy, for example, Dockerized applications, where everybody who runs in the container is always root. So you want to protect data from other people. So multi-tenant security is a key aspect of that. And so besides providing native access to that, we also have access through multiple different protocols. So we essentially allow the customer to access this data through their native POSIX client file system, but we also have an exporter through S3. We have an exporter through NFS, SMB, and HDFS. And so for the SMB and NFS part, we're using essentially CTDB, Ganesha for the NFS part, and we use some of the most recent versions of Samba. We're not yet on the very latest one, but we're planning to go there pretty soon. And so we essentially provide multi-node access through SMB. So as I said, one of those individual devices I shared with you before can deliver anywhere between 20 and 80 gigabytes per second per individual building block. And so each of them can run an embedded version of SMB, which is clustered between all the individual instances. And so you can basically build a massive scale-out SMB solution that provides access through multiple heads, combining the performance of all the individual building blocks to a pretty significant scale. So we've done tests in the lab, and we can basically linearly scale this up anywhere to 10 or 20 nodes and systems. And therefore, every time you add another node, you add several gigabytes per second throughput to it, to essentially the same data set that is stored behind that. And that's one way that we leverage Samba and the SMB export today in the company. So we also have enterprise products, as I initially mentioned. I want to mention a few of them just to give you an idea of what you're doing as well. So IntelliFlash is a company that we acquired quite recently. So just happened end of last year. We acquired a company called IntelliFlash from Western Digital, which was originally started as a startup company called Tagile, which some people may know. So Tagile internally is using an SMB stack that is leveraged in order to integrate primarily with hypervisors these days. We will come up with a new version of that in the not too distant future, which will add more general purpose NAS capabilities as well. So IntelliFlash has a very strong NFS stack today already, but the product primarily came from a block and virtualization background. So deep integration in VMware, deep integration into Hyper-V, all the various hypervisors essentially. And it comes basically in three flavors. There is an N series, an HD series, and a T series. And the main difference is really performance and scalability. The N series is basically the fastest of all. It delivers very, very low latency performance from block as well as NFS workloads, SMB workloads as well. But as I said, in the current release, primarily for hypervisors. And in the next release, we're going to open this up as a more general purpose NAS platform for SMB workloads as well as NFS workloads as well. So it is a unified system. So it basically has the entire capacity available to be sliced and diced between the different protocols. So it is a unified system. That means it has block and file access protocols at the same time. And it has some nice integration with Cloud DR. So if you want to synchronize data into an Amazon instance, for example, for DR purposes or backup purposes, you can do that. And it supports a very wide variety of workloads, primarily very mission-critical applications that require very low latency access, OLTP applications, and various types of databases. And some customers using it for super low latency analytics as well, where this product is very well suited. It has built-in compression and dedupe, which is making it very space efficient. So typical is people have around 60% saving, 2.5 times data reduction with production workloads, and all of that with super low latency because everything is inline and turned on all the time, which is one of the reasons this is differentiating significant with lots of the competitive products in the space, because we have all the enterprise features turned on all the time, but still can deliver a very, very high performance and low latency. Also here, one of those systems delivers around 20 gigabytes per second throughput for NFS or SMB workloads, which is a pretty high performance number for such a small device. And the last product I wanted to talk about is Tintri VM Store. So Tintri VM Store also leverages SMB under the cover. It's an implementation that was done by the Tintri development team itself. So they wrote an SMB stack essentially from scratch. And this SMB stack is highly optimized to only support virtualization workloads. So it is not a full implementation of an SMB stack. It basically only implements the bits relevant for SMB3 in order to interact with the hypervisor. But it does this in a very, very efficient way. Because it's not a full-fledged implementation, optimizations could be done heavily on performance and integration with hypervisors. And that's what this product is really all about, because the only thing it supports is really virtual machines from all the different hypervisor vendors. But it does this in a quite phenomenal way, because it essentially has storage allocations and assignment for every single individual VM, which means it can do quality of service on an individual VM level. And it comes with a very, very broad amount of analytics tools, allows you to immediately highlight if your problem is on the client side, if your problem is on the server side, if it's on the storage, if it's within the VM, maybe the VM has too high CPU utilization. That's why storage is slow. So it adds a lot of smarts and analytics capabilities to a storage product, which is pretty much unmatched compared to everything at least I've seen before, which is why VM Store is a very successful product in the virtualization market for SMB as well as for NFS attached workloads. So this is what I wanted to share about the product, but I also wanted to throw out two challenges to the community, because given I'm around the Samba team and that community for a very long time, I also want to provide some interesting feedback or ideas of what to look at next. So one of the challenges that we see in where we're using SMB today is, so imagine there is a huge market out there for customers that have very, very expensive equipment. This could be equipment that collects sensory data, equipment that does DNA sequencing. Some of the autonomous vehicle software stacks run Windows. And one of the challenges is that on none of these systems you're allowed to actually install any additional software. So even if you would have an awesome file system solution for Windows that delivers massive throughput and performance, you are not able to leverage with these tools, because the vendors sometimes have the product FDA approved, or there is any other regulatory reasons why you can't install any software. And the challenge these customers have today is that a lot of the data that they collect, they literally have to store to USB devices or something that is significantly faster than the network attachment that they get today for most products out there, and then basically move the data literally physically in order to offload it to a different system. And the reason they can't stream over SMB, particularly in case where Samba is used today, is that we just can't get the data rates that some of these instruments require. So some of these instruments, write very large files, multiple gigabytes in size. Some are in the hundreds of megabytes in size, but then it's typically multiple of them in parallel. And some of these instruments require that the data will be offloaded at a rate of 2 to 3 gigabytes per second. So we are not capable of seeing that today with SMB. So we see rates in the hundreds of megabytes per second. But what we're really looking for is the Samba community come up with an idea on how some of these workloads can be significantly enhanced. Particular challenging is that these systems are just Ethernet connected. So RDMA is also not really an answer. So any creative ideas in this area I would be very interested in. To give you an example of what other systems can deliver on a single stream. So this is a performance number I just picked out of our performance document to show what a single stream performance, for example, with our Exascaler product is. So this is a Linux client that I'm running on, and all I'm basically doing is I'm opening a file and I write that file with 1 megabyte IOs. So basically append 1 megabyte at a time to it. And then I basically read it back. And as you can see here, there has been quite some enhancements in the latest version of Exascaler, but that's not what I wanted to point out. What I want to point out is that with alternative protocols, getting 2.5, 3 gigabytes per second on write and anywhere between 2 and 4 gigabytes per second read is definitely achievable. And that is a single threaded workload. So this is not even a multi-threaded workload. So for multi-threaded workloads, these numbers go up very quickly and essentially are limited by the network adapter bandwidth of the system. So it's definitely feasible to do this if you do very large IO submissions at a time and if you use AIO or some other technologies to accelerate the IO path. And so it would be great if the Samba team can come up with an idea how to do that. Volker mentioned to me yesterday that with IOU ring, there already are some things in the pipe. And I promised to measure that with the latest code to see where we actually are. And I'm more than happy to provide some concrete data for people to look at. But that would be one thing that would dramatically make the change in where SMB can be used today in modern worlds where people, everything is about analytics and AI and machine learning workloads. So if SMB wants to have a place there, in particular with Samba, that would be one area to actually invest into. And another thing I would like to throw out to the community is there's huge advancements going on in the storage industry, and particularly with new stacks that are being developed from the ground in order to leverage the full advancements of modern technology, which is primarily RDMA networks and NVMe or some form of storage class memory technology. So imagine for a second you would have a vendor that could give you a super low latency key value store technology. So think about key value puts and gets in the tens of microseconds of latency. So really, really fast, delivered to you through a user space library that could be leveraged directly by Samba. The system is highly resilient, highly scalable to quadrillions of keys. It can go petabytes, exabytes in size, and it's completely elastic and resilient with essentially zero end user touch. So that means the customer just deploys a bunch of nodes and some software stack is providing a highly distributed key value store on top of that. How could you leverage that with SMB to provide an integration into the Windows or the SMB world in general, leveraging storage technology like that, where there is basically no POSIX file system, there is just a key value store, which is incredibly fast and has a couple of very cool features like automatic indexing of keys and multiple other things. And you can get ranges of values and ranges of key. So what would an ideal interface for SMB look like to run natively on top of a key value store rather than on top of a POSIX file system? And what would be the desired features and functions of a stack like that in order to accomplish this? And that is the end of my presentation.
So thank you very much. We have some questions in the question and answer.
Yeah, I just opened this up. Okay, Jeremy Ellison, are you able to say what the underlying file system is on the XF5 stack? I've wondered if you were using ext4 CFX. Yes, it's basically a modified version of ext4. So it has a couple of enhancements to ext4, but it's fundamentally relying on ext4. That's the answer to Jeremy's question. I hope I pronounced it correctly. Guo Albert, as you mentioned, your system supports SMB with Samba CDD and NFS with Ganesha. I'm wondering whether the system supports multiple protocol access both SMB and NFS for the same file system. The answer to that is yes. It supports access through SMB and NFS into the same file system, over basically the same directories through an NFS share and an SMB share at the same time. Jeremy, does IOU ring help with this? Well, that's the good question. So Volker mentioned that to me yesterday. I was not aware that you guys are doing anything in this area at this point in time. And I promised Volker I'm going to test it with the latest version, because the version we're using right now is, I think, 2 months old. And we definitely did not configure IOU ring. So I'm not really sure if it's going to help, but I'm definitely going to give it a try. Also, we can't change Windows 10 clients to make them use larger client IOs. Yes, I'm very aware of that. And I know this is a big challenge. One thing that would be interesting to look at is, and that's actually something that I would like to try out myself, Windows or Microsoft has basically announced that starting end of this month, I think, they're going to ship, which is only a couple of days, so I'm wondering if they meant May or June, they're going to make Windows Service for Linux, so WSL2, the default on the Windows 10 installation, if I read that announcement correctly, that might actually allow us to run an SMB client under Linux inside the Windows machine, but it still would be accessible through the Windows, the Windows Explorer, because there is deep integration of WSL2 together with the OS. So that might be an interesting thing. So if the Windows client, the native Windows client can't do it, maybe the SMB client running in WSL2 would be capable of doing that. Tom Talpe, it was mentioned that there are some systems where RNA is not an answer. Can you describe this in more detail? RNA is not a very different from ordinary networking. What is a blocker in your view? Well, that the networking cards in these machines simply are not RDMA capable. And so given that you can't change anything on the hardware and you can't change anything on the software, you can really only run whatever is installed on the machine. So if that machine doesn't have an RDMA capable networking adapter, there's just nothing I can do about that. Okay. Jeremy would like to brainstorm in the SMB Samba VFS KV store idea. Sounds a fun project to come up with a fake file system mapping that gets around limitation of POSIX. Yeah, that's exactly what I was looking for, Jeremy. We should definitely have a chat around that. Tom, how large an I/O are you thinking for these large Windows I/Os? Well, that's a good question. I mean, at the end of the day, a lot of this is bound by physics. So I think if you would be able to do 1 megabyte I/Os, you should be able to saturate the networking links, as long as you just have enough in-flight I/O going out of the system. So it's a matter of, what's the round trip time for an individual I/O. If the storage systems, like in our case, can handle I/Os at a very high rate with very low latency, I see no reason why you can't do that. So let's assume you have a round trip latency of, network round trip of 100 microseconds, and the storage system can eat the data in 200-300 microseconds. That gives you actually a lot of throughput, even if you would have a single threaded I/O with 1 megabyte I/Os in flight all the time. And so I think if we can get 1 megabyte I/Os to work, that should be really all that's required. If there's many files that is being worked on, 256, 128K might be actually good enough to really saturate the system. And so, yeah, I don't know what the answer to that really is. I can just tell you, if the latency of the system is low, which in our case it is, even having 1 megabyte I/Os in flight at any given point in time should really solve the problem. Alexander, not a question, just an observation. We used to have VFS modules that map Samba access onto SQL database around 2004. All lost probably. Okay. And then Tom, well, Windows does up to 1 megabyte I/O today, and it supports large windows of multi-express when the server agrees. So maybe this really boils down to a tuning question, which I doubt, because I think there has been lots of work done there already in the past. But I'm more than happy to take that chat on the I/O challenges and also the key value store offline or actually online on the summer mailing list if people think that's the right way to start the conversation, and then maybe we can continue that chat there. I think I answered all the questions. Yep. Okay.